Get the graph of polynomial functions satisfying the given conditions. Okay, they say we have one root of multiplicity 1. We have two roots of multiplicity 2. That's a grand total of 4 roots. Then we have one root of multiplicity 5. That's 5 more roots. So we have a grand total of 10 roots here. So this thing is of degree 10, which means it's either U-shaped or inverted U-shaped. And it's got a positive coefficient. So it's actually this one. It's going to be shaped like some kind of U. It's going to start in the top left. It's going to end in the top right. And in between, it has to do all these root things. So let's do those. I'll just do them in order from left to right. We need a root of multiplicity 1, which means it comes down and just cuts through the axis like it isn't even there. Then we need a root of multiplicity 2, which is what you get when you come up, touch the axis, and turn away. Then there's another root of multiplicity 2, so it comes up, touches the axis again, and turns away. And then a multiplicity 5 is what happens when it comes up, curves like it's about to turn away, and then says, nope, actually I am going to go through. That's what we call an inflection point, or an S-bend. So for multiplicities, we have 1 plus 2 plus 2 plus 5, grand total of 10. So this thing is of degree 10. They ask that at the very end, but I always work it out first because I want to know what the overall shape is. Is this thing shaped like a U or a lightning bolt or an M? You can get all that if you know the sign of the leading coefficient and if you know the degree. So even though they don't ask this until the very end, I encourage you to find it sooner. For example, 2 real zeros of multiplicity 1, so that's 2 zeros. 1 zero of multiplicity 3. A 0 of multiplicity 4, that's a grand total of degree 9. So 9s look like S's or lightning bolts. If they're positive, they go up like so. If they have a negative coefficient, they go down like this. This one has a negative coefficient, so it's going to start in the top left and go to the bottom right. And in between, here are the things it's got to do. Multiplicity 1 twice in a row, so that means it's going to come down, cross through the axis, turn around, cross through the axis again. That's those two taken care of. Now we need a multiplicity 3, which means an inflection point. It's got to come down, flatten out, like it's thinking about turning back, and then say, no, I am going to go through. That's our mult 3. And now we did multiplicity 4, which is a tangency, so it needs to double back, just barely touch the axis, and then carry on. I missed my little tick mark here, but the shape is still right. So for multiplicities, we have a 1, the inflection is a 3, and then this tangency is a 4. 1 plus 1 is 2, plus 3 is 5, plus 4 is 9, so this thing is of degree 9.